Next topic is permutation. So first we have to know what is permutation. Permutation means a bijective mapping, the set of all bijective mapping. All possible bijective mapping. You all know what a bijective mapping is. Bijective mapping means what is injective or one-to-one and onto mapping. We will consider all those bijective mapping on a set onto itself. On a set onto itself. That means first we are considering the set 1 to 3. Suppose S equals 1 to 3. This set. Then we will consider all possible bijective mappings of S onto S. Okay. How many ways these can be possible? First, we are considering this 1 to 3. 1 is mapping onto 1 to 3. Okay. And naming it as row 0. Next, we are finding the next bijective mapping, naming it as row 1, and we are taking it as 1 to 3, then 2 3 1, like this. Similarly, row 2, it can be taken as 1 to 3, 3 1 2. Then row 3 as 1 to 3, 1 3 2. Row 4 as 1 to 3, 3 2 1. And then row 5 as 1 2 3 2 1 3. Okay, these are the only possible bijective mappings on S, from S onto itself, like this. This is 1 2 3 S set, and this is also 1 2 3 S set. Just one map, the first one if you consider row 0, then here 1 is mapped onto 1, 2 is mapped onto 2, 3 is mapped onto 3. That means 1 maps 1, 2 maps 2, 3 maps 3. This is our row 0. Similarly, if you want to consider the next one, row 1, then how will you do that? 1 2 3. If we want to draw row 1 is this one, 1 2 3 2 3 1. That is 1 is mapped to 2, 2 is mapped to 3, 3 is mapped to 1. So let's see how will the diagram look like. So 1 mapped to 2, that is like this, then 2 maps to 3, this, and then 3 maps to 1. This is our row 1. Okay, this is how we can compute all row 0, row 1, row 2, row 3, row 4, row 5. So these are the only possible 6 distinct ways in which we can get a bijective mapping on the set S onto itself. Now these all total 6 mappings will form a group onto itself, and this group is known as symmetric group. Symmetric group, and it has a particular symbol. It's denoted by S3. S3 means symmetric groups on 3 symbols, 1 2 3 or ABC, like this type of groups. Okay, so S3 is our this group, row 0, row 1, row 2, row 3, row 4, row 5. Okay, and the operation is like the composition of permutations. Okay, now similarly, when we will consider 4 symbol like S, like this, 1 2 3 4. Okay, then we will get some new group which will be denoted by row 0, row 1, and so on. There will be total 24 elements. Okay, there will be total 24 elements, that is up to row 23. This will be our new symmetric group, and then we will name it as S4 because there is 4 element. So the symmetric group S4 contains total 24 elements. Let's check few elements of that S4. How we can get the bijective mapping of the 4 symbols 1 2 3 4 onto itself. So 1 2 3 4 can be mapped like 1 2 3 4. Then the same thing, 1 2 3 4 is mapped onto 1 2 3 4. Next we can take 1 2 are mapping onto the same thing, 3 4 has changed, 4 3. Then the next element we can choose 1 2 3 4. Then these two elements are changed, 2 1 3 4, like this. Next one could be 1 2 3 4, then 2 1 4 3, and so on. Okay, total 24 elements will be there. And how do I know that there will be 24 elements? Because the rule is for Sn the number of elements will be factorial n. Okay, for S3 we get total 6 elements, row 0, row 1 up to row 5. Okay, because that the rule was 3 factorial, which was 6. And for S4 we get total 24 elements, that is 4 factorial, which is equals 24. Okay, so similarly we can also define S5, S6 and so on, but those are not so important. Only S3 is very much important for the example, and for S4 you only have to know all these 24 elements. Okay, so try to find all the 24 elements of S4, and S3 is very much important. So these type of groups are called symmetric group, or sometimes it also called like permutation group also. The same thing, symmetric group or permutation group. Okay, and how many elements are there? The answer is factorial n. When it's S3 it will be factorial 3, which is equal to 6. When it is S4 it is factorial 4, which is 24. Next topic is integral power of an element. Integral power of an element. Suppose A is an element of a group G. Now A to the power n means composition of A n times. Composition of A n times. Okay, that means A composition dot dot composition A for n times. Okay, so if we write A square, it will be composition of A 2 times A composition A. Similarly, A cube will be A composition A, and so on. Okay. Next is order of an element. Order of an element. Order means, suppose we have a group G and A is an element, then we will say that A is of finite order, or A having the order n, if there exists a positive integer n such that A to the power n equals E. Okay, this n would be the least positive integer for which A to the power n equals E. Then we will say n is the order of A if A to the power n equals E. Okay, and we will denote it like this: order of A, small o, then in bracket A, this is equals n. That means A to the power n equals E. Okay, now we have few properties over order of a group or order of an element. Number 1 property is order of A equals order of A inverse. Both are same. Number 2 property is, number 2 is an important one. If order of A equals n, then for positive integer m, order of A to the power m equals n by GCD of m comma n. This property is very important for solving problems or examples. So let's solve one example using this property. That is, whenever order of A is equals to n, and then for any positive integer m, order of A to the power m equals n by GCD of m comma n. Okay, so the example is using this property. In a group G, A is an element of order 30. A is an element of order 30. Then find the order of A to the power 18. find the order of a to the power 18. Okay, so if we want to apply this theorem, then according to this theorem or this result, order of a equals 30. This is our n, right? And we have to find out the order of a to the power 18, that is m is equals 18 here. So order of 18, just use this formula, previous formula, it is n by GCD of m comma n. So n is 30 by GCD of 18 comma 30. Calculate the GCD of 18 and 30, it will be 6, 30 by 6, which is equal to 5. So order of a to the power 18 is equals to 5. Okay, these examples are very important and quite easy also.